Hello again, Year 10. In order to help you revise for your topic test on volume and surface area, we've set you this task as a revision lesson on class chart. Right, it is 2 sides. Now what I wanted to do is actually go through each of the questions for you so then you can mark your answers, and if you have got anything wrong, you can see where you've gone wrong. Alright, so the first question was something that should have been fairly simple. It's just the area of compound shapes. So the first one is this one here. It is a triangle and a rectangle. I'm just going to call them A and B. Now, if we look at A, the triangle, we've got a base of 6 meters. Now, the height is going to be 10 subtract 5.5, which is 4.5 meters. So therefore, we're just going to use the formula area is base times height divided by 2. So 6 times 4.5 divided by 2. So the area. Every question on this was a calculator question, so you can use it for each question. 6 times 4.5 divided by 2, and you should get 13.5 square meters. And the rectangle is 6 by 5.5. So the area is length times width, or base times height. It's good practice to always include your formula. So length is 6, width is 5.5. So 6 lots of 5.5 is 33 square meters. So the total area is 13.5 plus 33, which gives you 46.5 square meters. For the second part, this part here, we're going to actually split this into 3 shapes. So I'm going to call that A, that B, and that C. Now you could split this up differently. When you add your areas together, you should get the same answer. So this isn't the only way to do it. If I look at A, I've got a rectangle with a height of 11 and a width of 16. So the area, length times width, is 16 times 11, which is 176 millimeters squared. Now A and B are the same, or they have the same area. So A and B is 2 lots of 176, which is 352 square millimeters. Now C is a rectangle with a base of 52 millimeters. Now the height, this bit here is 11, the whole thing is 34, so this length here is 34 subtract 11, which is 23, so the height is 23. Area is length times width, so the area is 52 times 23, which is 1,196 square millimeters. So therefore total area is 352 plus 1196, which gives you 1548 square millimeters. So that's how you should do question 1. Question 2 is again still looking at area, but area of a trapezium. So we need to find the area of this trapezium. Now, you should know that the area of a trapezium is the sum of the parallel sides divided by 2 multiplied by the height. You may have been taught the formula written slightly differently, but you'll still get the same answer. So that's your A, that's your height. Notice it is the perpendicular height, not the slanter side here. So your height is 12, not 13. So just substitute into the formula. (18 plus 28 divided by 2 times 12 is 276 centimeters squared. So again, it should be really straightforward. Part B is a little bit more difficult because we have to work backwards. So we're told that that trapezium has an area of 35. So the area, again, get into a good habit, state your formula. Now we're told the area is 35 equals A, we don't know yet, but that's what we're going to try and work out, plus 8 over 2 times by the perpendicular height, which is 5. And we need to effectively solve that equation. So the first thing I'm going to do is I'm going to divide by 5. That gives me 7 is A plus 8 over 2. I'm then going to multiply by 2. And then I'm going to subtract 8. So you should get A is 6 centimeters. And that's your final answer. Okay, moving on to question 3. This is where things get a little bit more difficult. So we're now looking at volume of prisms. Now, like with any prism, or the definition of a prism is a shape that has the same cross section throughout the shape. So our general formula for the volume of a prism is the area of the cross section multiplied by the length. So volume is area of cross section multiplied by the length, or the height. So area of the cross section, in this case, which is the triangle, so that's base times height divided by 2, so it's this triangle here. Base is 4, height is 3, 12 divided by 2, 6 centimeters squared. So therefore the volume is 6 centimeters squared multiplied by the length, which is 6 centimetres, which gives me 36 centimetres cubed. Part B is compound volume. In other words, we're going to split the shape up. You could do it a different way, to the way that I'm going to do it. You could work out the area of this L shape and then multiply it by the length. I'm going to work out the volume of this cuboid and the volume of this cuboid and add them together. Either would work. So looking at A, the volume is going to be, well, the area of the cross section is 4. I'll show where I got that. 2 times 2, and then multiply it by the length, which is 6. So the volume is 24 centimetres cubed. B, the volume is, the area of the cross section is 2 times 4. The length is 6. So the volume is 8 lots of 6, which is 48 centimetres cubed. So therefore the total volume is going to be 24 plus 48, which is 72 centimetres cubed. And then the last one, volume of a cylinder. So the area of the cross section, I'm going to use pi r squared because it's a circle. So the area is pi times by 5.3 squared. Times 5.3 squared. Now I'm going to leave it as a fraction, so that gives me 2,809 over 100 pi. I'm not going to convert it to a decimal because it's a really long decimal. If I round now, then my answer won't be as accurate at the end. So therefore the volume is going to be the area of the cross section, which we've just worked out, 2,809 over 100 pi multiplied by 9.5. Notice I haven't cleared my answer off. Answer times by 9.5, that gives me 838.349. Give your answer to the nearest integer. That gives me 838 centimetres cubed. Okay, question 4. You are asked to find the surface area and the volume of this square base pyramid. You are told that the vertical height is the square root of 32. If you weren't told that, you would need something called Pythagoras' theorem, which you should have seen before, but I wanted to give you that piece of information so you didn't need to work that out. I've also given you the formula for the volume of a pyramid. That's because you would be given it in the exam. Okay, so the surface area I'm going to do first. So let's look at is a square, so its area is 4 lots of 4, which is 16 centimetres squared. Now, because the base is square, each of the triangular faces are the same. So if we look at actually one triangular face, more accurate, so one triangular face, the area base times height divided by 2. Base is 4, perpendicular height is 6, divided by 2. 24 divided by 2 is 12 centimetres squared. So all four triangular faces have an area of 48 centimetres squared. So therefore the total surface area is 12 plus 48, which is 60 centimetres squared. Sorry, 16 plus 48, which is 64 centimetres squared. Because the base is 16 or 12, apologies. Okay, volume. We're going to use the formula that we've been given. So the volume is 1/3 times by the area of the base, but we know the area of the base is 16. The vertical height, I'm told in the question, is the square root of 32. So the volume is 1/3 times by 16 times root 32, which is 64 root 2 over 3. Now, if the question said give your answer as an exact number or give your exact volume, that would be your final answer. It doesn't specify, so therefore we give it 3 significant figures. So that is 30.1698 and so on. 3 significant figures, so volume is 30.2 centimetres cubed. Okay, question 5. Quite a bog standard question. A sphere has a radius of 3 centimetres. Work out the exact volume. Now remember, exact means our answer is going to be in terms of pi, or it's going to be a third. And again, you're told the formula in the exam, so I've given you it. So volume is 4/3 lots of pi, lots of r cubed. So the volume is 4/3 times by pi times by 3 cubed. Now, if you stick that in your calculator, you get a volume of 36 pi. Just because we're given it as an exact value, don't forget your units. 36 pi centimetres cubed. If you gave your answer as a decimal, so if you gave your answer as 113.1, you would lose the accuracy mark because the question specifically said exact. Okay, question 6. Now this is something that's not necessarily been covered in the lessons you've just done, but it's still fairly straightforward and it's something you should have seen before. Limits of accuracy is basically a fancy way of saying upper and lower bounds. So a parallelogram has a base, draw a picture, a base length of 9.4 meters and a height of 8.5 meters. And both these measurements are given to one decimal place. So that means this 9.4 could be anything between 9.35 meters to 9.45 meters. And this height could be anything between 8.45 meters and 8.55 meters. So we're asked to work out the upper and lower bounds. Well, we know that the area is base times by perpendicular height. So if we're going to work out the upper bound, area is going to be the maximum possible height, which is 8.55 meters, multiplied by the maximum possible base, which is 9.45 meters. Okay, let's calculate 8.5 times 9.45. You should get 80.7975 square meters. And that to three significant figures is 80.8 square meters. Either of these answers would be fine. And very similarly, the lower bound so the area is going to be the lowest possible base, which is 9.35, times by the lowest possible height, which is 8.45. Multiply them together. Gives you 79.0075 square meters, and I'm going to give that to three significant figures, which is 79.0 square meters. Now again, either of those answers would be fine. So again, not that difficult. Question 7 is an area of a compound shape. Sorry, a volume of a compound shape. Or even surface area. Now, again, I'm going to split this into two shapes. Right. We're also told that the radius is 4 centimeters. So I could also add that onto my diagram if that's going to help me. Now that's important because it also tells me what the radius of the base of the cone is as well. Okay, so let's look at the cone. So we're asked for the surface area. Now I've told you the curved surface area of a cone is pi r L. Now L is the slanted length. In other words, that length there. So the curved surface area of the cone which is pi times by the radius, which is 4, that's why it was important, times by the length, or the slanted length, which is 8, which is 32 pi. I'm going to leave it as that for now. And because, actually, the question says give your answer in terms of pi. Now if I look at the cylinder, now the area of the base is a circle, pi r squared. So its area is pi times by 4 squared, which is 16 pi. Now, that's where things get a little bit more difficult for a cylinder. So the curved face, or the area of the curved face, the bit that wraps all the way around, well, we know it has something to do with the length 12, but the length that's all the way around is actually the same as the circumference of the base, or the circumference of the circular base. So the circumference of the base is going to be 2 pi r, which is 2 lots of pi, lots of radius is 4, so that's 8 pi. So therefore the curved area, or the area of the curved face, is equal to 8 pi multiplied by 12. Which is 96 pi. So I know the area of the curved bit of the cone is 32 pi. I know that the area of the bottom bit is 16 pi. And I know the curved surface area is 96 pi. So the total surface area is going to be 32 pi plus 16 pi plus 96 pi, which gives you 144 pi. And again, don't forget units, it's a surface area, so it's centimetres squared. So your total surface area is 144 pi. Question 8 then. Similar to the last one actually. This 3D shape contains a hemisphere, which is half a sphere, and a cone. But this time we're asked to work out the volume and give it to 3 significant figures. Okay, again I'm going to label the parts. So the hemisphere I'm going to call A, the cone I'm going to call B. So the volume of a sphere is 4/3 pi r cubed. So therefore the volume of a hemisphere is half of that, which is 2/3 pi r cubed. So that volume is going to be 2/3 times by pi times by the radius, which is 3 cubed. So the volume is 2/3 times pi times 3 cubed, which is 18 pi. Don't round yet. So that was for the hemisphere. For the cone, and then we know the volume of the cone is 1/3 pi r squared h. That's 1/3 times by pi times by the radius again, which is 3, times by the height. Now, we want the height of the cone, so we just want that bit there. Now, a sphere, if it has a radius of 3 centimetres, that means that distance there is 3 centimetres, but it also means that distance there is 3 centimetres. So that part there is 3 centimetres, which means this part here must be 11 centimetres. So therefore the height of the cone is 11 centimetres, not 14. Be careful there. So 1/3, lots of pi, lots of 3 squared, lots of 11, gives you 33 pi. So the total volume is 18 pi plus 33 pi, which is 51 pi. So that is 18 pi, 51 pi, which is 160.22. So on to 3 significant figures is 160 centimetres cubed to 3 significant figures. Okay, last question then. Asks us to work out the volume of what's called a frustum. Now, a frustum is basically a cone with a smaller cone or another cone on the top taken off. And again, we're told the volume of a cone. So let me just write down what I've just said. So the volume of a frustum is equal to the volume of the whole cone, in other words, all of that, subtract the volume of the cone removed. In other words, that cone there. So I'm going to call the whole cone A, and I'm going to call the little cone B. So if we look at A, we know the volume is 1/3 pi r squared h. So the volume is 1/3, lots of pi, lots of r squared. Now the radius is this 6 here, because I'm looking at the whole cone. 6 squared times by the height. Now the height is again of the whole cone. So the total height is 12 centimetres. We're told to give our answer in terms of pi. A third multiplied by pi multiplied by 6 squared multiplied by 12 is 144 pi. So that's the volume of the whole thing. Now if we work out, if we work out the volume of just a littler cone, very similar, volume third pi r squared h. Now in this case the radius of just this bit, so imagine the bottom bit isn't there, is 4. And the height is 8. I'm just interested in that part there. So the volume is a third, lots of pi, lots of 4 squared, lots of 8, which is 128 over 3 pi. Don't round it. So therefore the volume of the frustum is 144 pi, subtract 128 over 3 pi, pi subtract 128 over 3 pi gives me 304 over 3 pi. Now again, don't forget unit, even though we're given it as an exact value, centimetres cubed. Now please don't be tempted to write that as a decimal, because then it is not exact. So your final answer is 304 over 3 pi centimetres cubed. And that's it. And there is a summary of all of the answers. So I hope that you have found that useful, and good luck for your topic test.